Hello my friends, today I'll talk about this remote control. It's very old remote control and it don't use infrared to control or any kind of cable. It uses sound, ultrasound to control a TV remotely. It appears to work because there are a light when you press the buttons, and it uses two AA batteries. The only thing that I know that is Mitsubishi television, that it's made in Japan. I don't know more about it. I will show you and try to do a schematic of it. It's very thick, too heavy, and this light, I don't know, it seems to be a this light seems to be a neon sign. I don't know, I have to open and see it. I will open with you. There is some kind of technical resource used here. A piece of can, I don't know, as a spring of the battery. It's very old. Okay, let's open it and see what's inside. I think it's running with a germanium transistor. I don't know. It looked like very old. I never saw it in the other place. Oh my god. Okay. There is something wrote here. Date code 820118. I think it's 180182. Day, month, and year. 1982, maybe. I don't know. It's a spider here. A fossil. Okay, there are transistors here. Some capacitor, variable capacitors here. 1, 2, 3, 4, 6 buttons and 6 capacitors. I think it's each one for a frequency that is yes, I think each one is for a frequency of the resonator, the transducer here. It looks like ultrasonic transducer. I'll see it. Each frequency. I see about the frequency now. Let me see in the oscilloscope. Can I use it without the cover? It looks like yes. Is it working? Yes. Let me try to measure the frequency here. One of the wires is the mounting thing, the encapsulation of the transducer. I try to look up at the terminal here. Yes, I look it up. Let me see. It's a sine wave of 34.6 kilohertz. Let me see the other. 38.5 kilohertz, the plus volume button. The minus volume 40 kilohertz. The channel up 33.4 kilohertz. The channel minus 34.6 kilohertz. The mute button 34.8 kilohertz. and the on-off 37.1 kilohertz. Oh, this voltage is strange. 58 volts? Is it right? The amplitude is 160 volts. Peak to peak 170 volts. Oh my god. With two AAs. I think it's some kind of booster converter here. It look like an inductor. Let me see. This capacitor is rated for 16 volts. Okay. Let me continue to explore it. It works in the ultrasound frequency of about 30 hertz. Okay. The range of. So the human here have an approximated range of 64 hertz to 23 kilohertz, and the dog have 67 hertz to 45 kilohertz range, and the cat 45 hertz to 64 kilohertz. So this remote control can irritate some pets, I think, but I don't want to try with my girlfriend's cats. Because it can hurt, I don't know. So that's the frequency range of some animals. It is really ultrasonic because the human ear is up to 20 kilohertz. Okay, it's looking like very old. Oh my god, it's a neon. The transducer needs high voltage to operate, and they seems to use the high voltage to light up as a neon. Let me see. Is this the same voltage that goes to the transducer? I think yes. Or I don't know the circuit, but it can help some filter. I don't know. Let me see. Let me hook up this here and this here. And press the button. Yes, it's the same. Oh, it's higher. The amplitude is higher here. About 192 volts. My god. You can do a taser with this. And now you can see the printed circuit board. It appears to be handmade. I don't think they used CAD to do it. The buttons are pressed and put some contacts in the PCB to close the circuit. Okay. I'll try to do a schematic to it. There are springs and it's very used because it is oxidated here. Very oxidated. A neon sign not a LED to sign that the protons was pressed. It's very nice. Let me see something that I can see here. I think the capacitors are the same code used today. 100, 1, 102. A very large resistor. Some diodes. I think, let me see about this diode. Just diode. I don't know if it if it is diodes. I can see the code. I'll try to write a schematic. The transistor is B172. Yes, I think it's germanium because they look like it. It look like it. I'll try to do schematic, okay? Subscribe to my channel and like it too. I'm trying to do my best. I need more money to buy a camera and other computer too, and do some professional work. Okay, I will try to write the schematic, do the reverse engineer. So here is the circuit. Two batteries in series. The positive of the series is connected on the emitter of the transistor, that is the germanium one, B172, the name of transistor. The base of the transistor is connected via a capacitor to one coil of this transformer, variable transformer, tuning transformer, and the collector is connected in other coil of the transformer. The coil is connected to the switch, and every switch is connected here to the ground, and you press one of these switches, you connect the ground, this ground with this ground. And here is a filter capacitor, and every switch have a variable capacitor and a capacitor. A variable capacitor to do the fine calibration of each frequency. The secondary of the transformer is directly connected to the neon and to the transducer via a capacitor, right? The neon here is connected, I think it is wrong, let me see. It's connected by directly to the secondary of the transformer, yes, and via resistor. Oh, it's wrong. A resistor to via resistor to the earth. The switch earth. Sorry for the mess. It's not here. The resistor is connected to here. So the neon is connected to. No, it's not connected. Stop. Is the neon is connected directly on the secondary of the transformer, and the resistor is connected to this ground. I wrote wrong there. And this is connected here as a secondary to resonate in a frequency. This is the rectification. One from the transducer, the other for the, I don't know what it is, but it's connected like this. Transducer via a capacitor and neon directly. Because of it, the voltage here is higher than in transducer, like I measured. So basically it is a variable resonance transistor that is controlled by a transformer and capacitors. Okay, bye bye, see you.